Our final type of function that we're going to talk about in this extension is absolute value functions. So with absolute value functions, we're going back to the idea of having parent functions. So our parent function for an absolute value is f of x equals the absolute value of x. This is the most basic absolute value graph you could possibly have. So it's pretty simple as long as you remember what an absolute value does. So let's just start with a table of values so we can see what this parent function is going to look like, and then we can talk about how adding and subtracting and doing different things to this parent function will change the appearance of our graph. So let's start off by plugging in a bunch of points just to see the general shape of our graph. Let's start with the bottom half. If I put in 0, the absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. So right off the bat, you're going to see that some of your graph looks like this. And you're going to look at this and you're going to think, oh, that just looks like a normal linear function like y equals x. Why on earth do I have to do a separate section for this? But what we need to look at is what happens to the negatives. Remember, the absolute value of a number is always going to be positive. We can't take the absolute value of something and get a negative. So when I take the absolute value of negative 1, I get positive 1. When I take the absolute value of 2, I get positive 2. When I take the absolute value of negative 3, I get positive 3. So when I graph those points, when I put in negative 1, positive 1, negative 2, positive 2, negative 3, positive 3, I see that this is like a reflection over the y-axis, or my graph makes a V shape because all of my negative x values are resulting in positive y values. So this is what our parent function for f of x equals the absolute value of x looks like. From 0 on, my graph is just y equals x, or f of x equals x. But when I'm going from 0 to negative infinity, or I'm going in the negative direction, my graph is actually y equals negative x, or y equals the opposite of x. So this is what we want to keep in mind as we go through and we look at other functions. Okay, so what I'm going to do now is on this same graph, I'm going to look at the graph of the absolute value of x plus 3. And until I really figure out what adding and doing stuff down here does to my graph, I'm going to make a table of values to figure out what the graph should be. So again, I'm going to want to make sure that I pick some negative numbers and some positive numbers. If I don't do that, then I'm only going to get half of the graph, and I'm not going to get a very good picture of what's happening here. So let's try all of the points that we did before. Actually, we don't need to do quite all of them. Negative 2, negative 1, 0, 1, and 2. So when I put in negative 2, I get the absolute value of negative 2 is positive 2, plus 3 will give me 5. The absolute value of negative 1 is 1 plus 3, which is 4. The absolute value of 0 is 0 plus 3 will give me 3. The absolute value of 1 plus 3 will give me 4, and that will be 2 plus 3, that will give me 5. So I can kind of see that my numbers are going down and going back up. That shows me that I'm going to be able to see that V shape in my graph. So if I graph these, I have 0, 1, 2, 3, negative 1, 4, and positive 1, 4, negative 2, 5, and positive 2, 5. So that gives me a pretty good general idea of the shape of my graph. And I can see that it looks like an absolute value graph. I have the V shape. but my parent function has been shifted. My parent function, originally this vertex down here was at 0, 0. Now it's at 0, 3. This was at 1, 1. Now it's at 1, 4. So every point on this parent function has been shifted up 3. If I look at the function that I was given, the absolute value of x plus 3, that plus 3 tells me that I had a vertical shift. So I could say a vertical translation up 3 units. Or every single point was shifted up 3 units. And another question I could answer about this would be, what is the domain and what is the range? And actually, I can go back and answer that. Let's answer that about the parent function first. I forgot to do that. So with our parent function, you can see that I can pick any value I want for x. There are no limitations to what I'm allowed to plug in for x. So the domain, or my inputs, or my x values, is all real numbers. And remember, I can show that with the double bar r. Or all real numbers. There are no limits to what I'm allowed to plug in. But my range is what can come out for y. And if I look at this, my graph can never be less than 0. Or all of my points are going to be at 0 or above. So for my range, I would say that y is greater than or equal to 0. It can be 0, and it has to be anything at 0 or above. So now I want to look at my pink graph, and I want to see how that is, how my domain and range have changed. My domain hasn't changed at all. X can be all real numbers. I'm still allowed to plug in anything I want. But when I look at my range, because my graph was shifted up 3, now I'm not going to get any values that are less than 3 out. So my new range is going to be y is greater than or equal to 3. Okay, for this next one, I'm going to try something that's a little bit different. And let's have, my parent function is still the absolute value of x, which you can see I drew on purple in here again. Let's try the function, let's say g of x equals the absolute value of x plus 3. So remember my pink graph from before, I can put that one back on here just so we can be reminded. Looked something like this. So that was when I had the absolute value of x, and then I added 3. Now you'll see this time it's a little bit different. I'm adding 3 inside of that absolute value sign. So again, I can make a table of values just to try and figure out where this graph is going to wind up. So what I want to do, let's do -3, -2, -1, 0, and 1 to start off with, and see if that helps give me the shape that I'm looking for. When I put in -3, I get -3 plus 3, which is 0, and the absolute value of 0 is 0. When I put in -2, I get -2 plus 3 is -1, the absolute value of that is 1. -1 plus 3 will give me 2, and the absolute value of 2 is 2. 0 plus 3 is 3. And if I look, my numbers are just going up from here. I can tell they're just going to keep going up. And because I know what the basic shape looks like, I can see that I might need to pick some different numbers. So let's pick some numbers that are less than -3. Let's pick -4 and -5 and see if those help me figure this shape out a little bit better. If I put in -4, -4 plus 3 is -1. The absolute value of that is +1. So now I can see, if you think about it as being over here, now I can see that that 0 is my turning point. So I can guess that my answer here is probably going to be 2. Let's see. -5 plus 3 is -2. The absolute value of that's +2. So if I graph these points, when I put in -3, I get out 0. If I put in -2, I get out 1. If I put in -4, I get out 1. So there, I can see what my graph is going to look like. I could plot all those points also, but that would take me a while, and I think you get the point. So when I graph when I graph this, it's not very good, but you can see that I have the same shape. It's just been shifted. And in this case, instead of being shifted up or down, I've actually been shifted to the left. So we would call this a horizontal translation. Oops, Horizon. Horizontal translation. And this one over 1, 2, 3 units to the left. So when I added 3 inside of the absolute value, I shifted to the left, or I moved in the opposite direction of what you would expect. I didn't quite go through that line, but there you go. So when I added outside of the absolute value, my graph moved up. When I added inside the absolute value, my graph moved over. And that's something that you're going to notice as we do more and more parent functions and translations. If something is attached to the x, or it's in with the x, that's going to affect where that graph shows up horizontally. If it's stuck on the end, that's going to affect where the graph is vertically. So that's the general idea behind absolute value functions. And let's look real quick before I forget again, the domain and the range, and see how they've changed. The domain, I can still plug in anything I want for x. So x can still be all real numbers. And with my range, because I didn't move my graph up or down at all, my range is still going to be y is greater than or equal to 0. So because my graph wasn't affected horizontally at all, my graph wasn't affected vertically at all, I'm not going to change my range at all.